All right, so having known, welcome to today's video. We are looking at factors. It's like we can call it factors of whole numbers part 2. Here we are going to be considering the factors of two numbers. Then we'll identify the one that is considered to be the HCF. That's the highest common factors. Now, factors of 8 we know are 1, 2, 4, and 8. Now, factors of, let's say, 6, numbers that can divide 6 are 1 times 6 is 6, 2 times 3 is 6, 3 times 2 is 6, and 6 times 1 is 6. So 1, 2, 3, 6 are the factors of 6. If you check among these factors, we tend to have some numbers repeating, as in numbers appearing in both in among the factors of 8, and for instance 1 appears. You can see that 1 is appearing, 1 is appearing, 1 is up, 1 is down, 2 is up, 2 is down, but 4 is up, 4 is not down, 8 is up, 8 is not down. So we only have 1 and 2 to be the common factors. So 1 and 2, they are common among the factors of 8 and 6. So the assignment now is, which of them do we refer to as a HCF? HCF simply means the highest common factor. Now, 1 and 2 are common. 1 and 2 are factors of 8 and 6. But which of them is the highest? Is it 1 and 2? No. Among the factors of 8 and 6, 2 is the highest common factor. 2 is common. 2 is a factor of both 6 and 8. That is why it is common. And 2 can divide to 8 and 6. That is why it's a factor. And 2 can be found among the factors of 8 and 6. That is why it's common. So what I'm saying is that 2 is common because you can find it in among the factors of 8 and 6. And 2 is also a factor of 8 and 6 because you can divide 8 and 6 without remainder. And 2 seems to be the highest number that is common, and actually the factors of both 8 and 6. Hence, we'll say that 2 is the HCF of 8 and 6. So if you're asked what's the HCF of 8 and 6, the answer is actually equals to 2. So 2 is the HCF of 8 and 6. All right, so let's have some other example. That means the highest number that can divide 8 and 6 without remainder is 2. Okay, so let's have some other examples. Let's have values like let's say 10. Let's pick 10 now. Let's go with 12 and 12, and let's say 12 and 8, for instance. Now, factors of 12, we have 1, we have 2, we have 3, we have 6, and we have 12. You see, while factors of 8 will have 1, like we have 2, we have 4, and we have 8. You see, so if you check like we did before, our HCF is what we are interested in. Now, the numbers that are common here, the factors that are common here, among the factors of 12 and 8, 1 is common, 2 is common, 4. Okay, we are supposed to have 4 here too. Sorry, supposed to have 4 among the factors. 4, supposed to have 4 as well. Among the factors of 12, we're supposed to have 4. Supposed to have 4 here. Also have 4. Then we can now have 6. Okay, so among the factors of 12 and 8, we can see that 4 is common. 4 is common. 4 is common. Let me separate this with a comma. 4 is common. 2 is also common. 1 is common. But 3 is not common. 6 is not common. 12 is not common. So the common numbers we have, common factors we have 1 is common, 2 is common, 4 is common. And among these 1, 2, 4, of course, the highest of them all is 4. So that's why we say that the HCF of 12 and 8, 12 and 8, 12 and 8 is equals to 4, because 4 is the highest number that can divide 12 and 8 without remainder. Of course, apart from 4, there's no other number that can divide 12 and 8. The biggest number that can divide 12 and 8 without remainder, it has to be 4. Let's take the last example so the video doesn't get too lengthy. You understand what I mean? So let's have let's say we have odd numbers now, 15 and 9. For 15 we have 1, we have 3, we have 5, then eventually have 15. For 9 we have 1, we have 3, then we have 9. Obviously, for the factors here, in terms of, they are all factors, so looking at what is common using C, for what is common, 1 is common, 3 is common. There's only 1 and 3 that is common. So the highest of them all, of course, the highest of them all will be 3. Of course, 3 is the highest common factor. So we can say, therefore, that the HCF of 15 and 9 is equals to 3. You see, so that is how we go about finding HCF. Why are we learning HCF? Why is it important for us to learn HCF? Is because we are going to be diving into the next subtopic called factorization. And not only in this maths, this lesson, as you progress in maths, there are some situations that will require you to factorize either variable or whole number. So in that case, you need to have the skill, because it will be required of you. These are the basic foundational knowledge you need in maths as you are moving up into the ladder of excellent and more technical topics and questions. So the next thing we're going to look at is factors. We can call it factors. Is that part 3 now? Factors part 3. We'll be looking at the HCF of variable. These are numbers. Let's look at the HCF of variables. HCF of variables. Okay, so thank you for watching the video. You can check the description below to see to watch that video on HCF of variable.